Hi, welcome. We are on our first set of explanations for some pages in our practice for organic. So if you're in Mrs. Davis's class, this is going to be page 89 in your blue books. All right, so let's get started. I think we're going to just choose our color. I like green for organic. All right, so when we're naming hydrocarbons, the first thing you need to do is you need to count the longest chain of carbons that you can find. It means you have to count in every possible direction. So in this case, I have 1, 2, 3 carbons in a row. So then I'm going to work from the end of the name forward. So I need to figure out what prefix means 3 carbons. So I'm going to go to my reference tables and I'm going to go to table P. So then I have 3 carbons. According to my worksheet, they're connected by single bonds. So then it's going to end in ane. So then going back to my worksheet, I need the word prop, and then I'm going to use the ending ane. So then I'm going to use prop. Oops, let's go back to my pen. And I'm going to use prop, and here we go. So prop, ane. Circle the longest chain of carbons. Notice there's no other carbons outside of my long chain, so that means there's no branches. So that sounds good. Okay, so I am going to go on to number 5 over here because I think it's a little easier to just do what's on the screen first. All right, so first step in naming organic compounds, count the longest possible carbon chain that are connected carbons, right? That's what a chain is. A chain is connected. If it's not connected, it's not part of the chain. So I have 1, 2, 3, 4 carbons connected in a row. And I'll count backwards. 1, 2, 3, 4. So 4 is the longest chain of carbons that I can count. So I need to grab my prefix for 4. That's but, right? That's over here. And now it's connected by single bonds, so we're going to end in ane. All right, so then I've got 4 carbons. That's but. And then it's connected by single bonds, ane. So far, so good. Is there any branches if I circle my longest hydrocarbon chain? Are there any carbons outside of my chain? No. So there's no branches. All right, let's go on to question number 2 over here. So always the first step, count those carbons. Longest chain of connected carbons you can find. 1, 2, 3, 4. If you don't lift up your pencil, they're connected. Now go backwards. 1, 2, 3, 4. So I'm going to circle my longest carbon chain. Are there any carbons outside my chain? No. So I'm going to get my prefix for 4, which we already used, which was but. And now, let me erase so you can see this a little bit better. I have a double bond. So going back to my reference tables, a double bond, right, over here ends in ene. So now I'm going to change the ending to ene. And then don't worry, there's no pronunciation test. This is butene, right? And then my longest carbon chain, any carbons outside my chain? Nope. So no branches. We're good to move on. Okay, so question number 6. First step, always count the longest carbon chain. So 1, 2, 3. Now backwards. 1, 2, 3. Oh, there's one up there. 1, 2, 3. 1, 2, 3. 3 is the longest I can count. So then I am going to circle my longest carbon chain. Any of the 3 carbons that you circled would be fine because it's going to be end up the same anyway, right? This is just a 2-dimensional drawing of a structure that exists in 3 dimensions. So count the longest carbon chain, which is 3. So then back up here in question number 1, we agreed that the prefix for 3 is prop. So I'm going to do prop. And now it's connected by single bonds. So according to table Q, that means ane. Now, there's a branch outside of my carbon chain. There's a carbon outside my circle chain. So now I've got to label that as a branch. All branches end in YL, and we put branches before the long carbon chain, right? So the branch name gets named before the tree name. So then I count how many carbons are in the branch. So that's a 1 carbon branch. The prefix for 1 is going to be, oops, wrong page, is going to be meth, right? So meth. So then we're going to go over to our worksheet. We're going to call this methyl propane, METHYL. So now I need to give a location, possibly. So this branch can only be in one spot, right? Because with 3 carbons, there's only one location for it to be. If it's here at the top or if it's here on the bottom, in 3 dimensions, it's exactly the same, right? If you mentally rotate that. If I took this and I stuck it over here, then it's no longer a branch. Then it would be a 4 carbon chain. Then it would be butane. So it can't go over there. So the only place that it can go is in this center position. So there's no number necessary. If you gave it a number, you probably wouldn't get it marked wrong, but it's just considered bad, chemistry manners. All right, so let's go on to the bottom half of our screen. Okay, continuing with green. All right, first step, always count the longest carbon chain that you can count, right? Connected carbons. So 1, 2, oops, need the pen. So 1, 2, 3. Backwards, 1, 2, 3. The longest connected chain I can find is 3. So we've already agreed that the prefix for 3 is prop. So it's going to be prop. And now I have a triple bond here. So then when I'm circling the longest chain, now I'm going to go back to my reference tables and say, how does a triple bond get named? So I have that triple bond down here at the bottom. And you see that in yellow? All right, triple bond ends in YNE. So I'm going to go back to my worksheet, and we're going to end this in YNE. Are there any carbons outside of my long carbon chain that I circled? Nope. So there's no branches. All right, let's move on to question number 7. First step, always count the longest possible carbon chain. 1, 2, 3, 4, 5. Backwards, 1, 2, 3, 4, 5. Okay, 5, the longest carbon chain I can count. So I circle my longest carbon chain. Are there any carbons outside my chain? No. So there's no branches. Great. So then I'm just going to do this, and I'll circle that back up. Okay, so 1, 2, 3, 4, 5 carbons. The prefix for 5, according to table P, is pent. And we have a double bond. So according to table Q, the one with the double bond ends in ENE. Okay, are we okay? Are there any branches? There's no branches, but I have to give a location of that double bond that the arrow is pointing to, because there's more than one possible spot, right? It could go there. So, right, so then I'm going to say I want to start, it's closest to this side of the molecule. So that's the side I'm going to start counting on. So does it come after carbons number 1, 2? So is that 2 pentene, or would I call it 1, 2, 3? Well, nope, I'm not going to call it 1, 2. I'm not going to call it 3, because that is the larger number. I have to use the shortest, smallest number that I can count. So that's going to be 2 pentene. Okay, so let's move on to the next question. So I am going to go back to green, and I'm going to count the longest possible chain of carbons I can find. 1, 2, 3, 4, 5. Now backwards. 1, 2, 3, 4, 5. Can I count any other carbon connected chains? Yes, I can. I can go 1, 2, 3, and 1, 2, 3, 4, 5. So 5 is the longest chain that I could count. So I am going to circle the longest chain of connected carbons. There's my parent chain. That's what we call that. So then we already agreed that the prefix for 5 is pent according to table P. And now I'm checking for branches and any double or triple bonds. So I do have a branch, right? This is my branch right there. And so I need to give that a name. So I have single bonds, so that is ANE. And I have a branch. The branch gets a YL. We put the branch in the front. How many carbons in the branch? 1 carbon in the branch. So then this is going to be methyl pentane. But that could be in more than one location, right? It could be here or it could be there. If I put it over here, it's the same as that. If you mentally flip that molecule over, like you're flipping a piece of paper over, right? Because remember, this is a 3-dimensional real molecule that we're just drawing in 2 dimensions. So now I need to count, and I have to say what carbon is that connected to. So since it's closer to this side, I think I'm going to count that as from that direction. So it's carbon number 1, and then now this is carbon number 2. So then it is 2-methyl pentane. So far, okay? That next one looks pretty awful, doesn't it? But again, we just follow our steps. We're going to count the longest chain of connected carbons, as many possible directions as you can. So 1, 2, 3, 4, 5. Okay, 5 in that direction. Now let's go backwards. 1, 2, 3, 4, 5. So now 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, it's 5 in any direction. So the longest chain of connected carbons is 5. So circle a 5-carbon chain that's connected, since that's the easiest one. Doesn't matter which one you circle, the name comes out to be the same. Because remember, this is a 3D molecule that we're just drawing in 2 dimensions. So we agreed that 5 is the prefix, pent is the prefix for 5. So we're going to say this is pent. And it's connected with single bonds, so we say ANE. So that's pentane. So now, are there any carbons outside of my chain? Yes, there are. I have a branch here, and I'm going to use a different color because I want you to really understand that there's 2 separate branches here. This is not one very long branch, right? Because the branch has to come off of the tree, okay? So then when I'm naming this, the parent chain is pentane. Now I have 2 branches. I've got this branch, which I'll name first, that has 2 carbons in it. So then that's the prefix F. So then right from table P. So then I'm going to name that YL because it's a branch. So then now I have another branch over here. It also has 2 carbons. So I'm going to call that ethyl as well. But I don't want to say ethyl pentane, since they're 2 of this same branch, just opposite sides of the tree. I'm going to say that is a diethyl. So now the last step is I have to say location-wise on our main parent chain, where is each of those ethyls. Every branch gets a number location, just like every house on the street gets a house number, even if they're across the street from each other, like these are, right? So then I have to count in the shortest possible direction. So 1, 2, 3, or 1, 2, 3. So no matter which way I count, it comes out that those 2 branches are coming off of carbon number 3. So then both need a number. So then I'm going to do 3, 3, and a little dash between numbers and words. So that's 3,3-diethyl pentane. All right, so if you followed along and if you got these right, great job. And if not, that's okay. I'd like you to re-practice those. And you can always contact Mrs. Mitiga or myself, Mrs. Davis, through email or through the Google Classroom, and we'd be happy to help you further. Thank you. See you next time. And next time we are going to talk about drawing the structures of hydrocarbons.